The last part of the first section in chapter 4 is now looking at this C value that we've written at the end of every answer. We said that when we write our integral answer and we put the plus C, we refer to it as a general solution of the differential equation. Well, we're going to finish with talking about what it takes to find what's called a particular solution. And so our particular solution is figuring out what is the C value. So we talked on the very first day that when you have solution curves that represent a few of the general solutions, obviously you can't put infinite on there. If I wanted to know which particular curve it was, I would actually need to know a point on that curve. And that's really what we're going to focus on in this last part is if I want to figure out the C value so I can find particular solution, the exact curve that we're talking about, all we need to know is a point. So as long as they give us an xy, or if they write it like f of x equals y, any type of, sometimes it's called an initial condition, especially when you're dealing with motion problems, we refer to it as an initial condition. What do we know to start? That's enough information to find our C value. So I want to show you a few of them just to kind of give you an idea of what's happening. And then I want to show you how Delta Math asks it with a motion type of problem. So what they'll do is they'll give you the derivative. So your first job is to integrate that derivative. So when I do that, the integral of 3x squared is x cubed. Integral of 1 is x plus c, and this is going to equal my original y. And then you're going to use your point that's given. So you're given an x and y, plug in. It's truly just a plug and chug. So you have 4 equals 2 cubed plus 2 plus c. Sometimes the arithmetic's harder than the calculus. We get 10 on this side, so we're going to subtract 10. And that gives us our c value. So our particular solution will be x cubed plus x minus 6. Once I know what that C value is, I can plug it in at the end and get this particular solution. Here's one that's written in a rational form. Again, anytime you have a rational form, you want to write it with a negative exponent. They present the initial condition a little differently. The number that's in parentheses, that would be your x value. The number after the equal sign, that would be your y value. And the reason they tell us that x has to be bigger than 0, that's basically making sure that it fits on the domain. If x was 0, then we would end up with something that is undefined. So that really isn't going to impact your work. It's just making sure that we're looking at something that's where it's defined. So power 1 greater divided by that power. We're going to clean it up and write it as negative 1 over x plus c. That is, again, your general solution. Then you're going to put 0 in for y. You're going to put 1 in for x. Add 1 to the other side. So your particular solution is negative 1 over x plus 1. It's also possible to do these kind of further back. What I mean by that is you can actually start with a higher order derivative and integrate and work your way back to the original. But with these, you would have to have more given information. So for example, you're starting with a second derivative. You need to work your way all the way back to the original function. They have to give you given pieces along the way. So what I mean by that is if you integrate 2, you get 2x plus c. That's your first derivative. Because I started with a second derivative, if I integrate once, I have a first derivative. So now I need to plug in what I know about the first derivative. Well, I know the first derivative equals 5 when x is 2. So then I subtract 4. That gives me the particular solution for the first derivative. Doesn't get me all the way back to the original yet. Then I have to integrate again to get back to my original function. Integral of 2x is x squared. Integral of 1 is x plus c. Now I'm going to use this piece of information to find that c value because that's part of the original function. So 10 equals 2 squared plus 2 plus c. So we can subtract 6, so we get c to be 4. So my final answer for my original function is x squared plus x plus 4. So we could actually work back from several derivatives, but every derivative I have, every time I integrate, I have to have an initial piece of information for that to get it to be particular. So let's talk about how this relates to position, velocity, and acceleration. I'm going to add a slide in here. So if we think about position as being our original function, and then we derive it to get velocity, and then we derive again to get acceleration. Well, now we're going to work the other way to go in reverse. So now if I have acceleration, I'm going to have to integrate that to get velocity. So if I integrate acceleration, I get velocity. If I integrate velocity, I get position. So derivatives took us forward. Start with position, derive for velocity, derive for acceleration. But integration will take us in reverse. Start with acceleration and integrate, I get velocity. Integrate again, I get position. So here's what they're going to do on Delta Math. They're going to give you a velocity equation. These are all focused on velocity and position. It doesn't get into acceleration yet. And they're going to tell us an initial condition. They're going to tell us that when t is 1, we're at a position of -9. They use x to represent position. And the question wants to know what is the position when we get to t equals 3. So we need to start off by integrating this velocity function. You'll notice with these, everything's going to be in terms of t, in terms of time, because it is motion. So the integral of -12t is going to be -6t squared. The integral of 10 is 10t plus c. That's going to give you, not velocity, that's going to give you a position equation. Then they give you that initial position to help you find your c value. So they tell us that my position is -9 whenever t is 1. So that's going to give me -6 plus 10 plus c. So you have to do a little arithmetic here. You end up getting 4, so we're going to subtract 4. So you get -13. But I want you to notice how we use this. So now we have this position function that is -6t squared plus 10t minus 13. That is a particular solution, meaning we have that exact c value. Now we answer the question, which is what happens when I put a 3 in for time. So you actually have to do all the other stuff first before you answer the final question. And again, a lot of arithmetic here. If you want to use a calculator to make sure you don't mess up your arithmetic, that's fine. So we end up getting 3 squared is 9 times -6 is -54 plus 30 minus 13. And again, if you want to grab a calculator and just make sure that you're on the right track here, you can type in -54 plus 30 minus 13 to get your answer. And it is perfectly fine to get a negative position. It's basically just talking about where we end up. You're not going to have negative times. Your time is going to be restricted to 0 and up. So let me show you one more motion problem to make sure you're comfortable. So again, we're going to integrate our velocity because that's going to give us a position function. So my position function when I integrate is going to be t cubed minus 10t to the second over 2 is going to be 5t squared plus c. Then I'm going to take my initial piece of information. That's why it's often called initial condition, because it's usually referencing motion. So I'm going to put -8 in for position, and I'm going to put 2 in for time. So I get 8 minus 5 times 4 is 20 plus c. So that ends up being a -12. So I'm going to add 12 to both sides. So I get c to be 4. So that tells me that my position function is t cubed minus 5t squared plus 4. And your c value can be anything, positive or negative, doesn't even have to be a whole number. And then finally, I want to answer the question, which is what happens when I put 3 in again. I do like the fact that they tend to work with small numbers, just keeping it a little simpler. This calculator's still nice to just double check your arithmetic. So I get 3 to the third minus 5 times 3 squared minus 5 times 3 squared plus 4. So my position at 3 would be -14. And all you are plugging into Delta Math is your final answer. So that is how we find C, and that's also how we use C. As long as you have an initial condition and the ability to integrate, you can always find a particular solution.